Hello everyone. So today we will be continuing with the from the previous lecture with Hyperledger Indy, and we will see that how we can use Hyperledger Indy for using digital credentials and through verifiable presentations. So the concepts covered in this lecture are Hyperledger Indy verifiable credentials and presentations. So we will go through a hands-on tutorial on how we can use Indy to validate claims from different participants using these digital credentials. So the keywords for this lecture are Indy, verifiable credentials as well as verifiable presentations. So we will be continuing with the same scenario of three participants, the university, Alice and a company. So here Alice needs a transcript credential issued by the university which she wants to present to the company for job application, and Indy will be helping in all of those steps. So the till the last lecture we saw that we were able to configure the identities for the different participants, the university, company as well as the government. So in this particular lecture we will go through the next steps. Okay. So here we will see that the first step would be to register a credential schema. So for each verifiable credential, the format of the credential, the different fields, the different encoding formats, etc., those have to be fixed. So for a transcript also that is supposed to be issued by a university, that has to be standardized. So for that credential schemas are used, and here we will be using the transcript credential schema that would be issued by the government. So that is the reason why in the last lecture we also initialized a participant called government and registered its identity using this tool. So the next step, step 5, would be to create credential definitions. So credential schemas are basically structure of a credential or the different fields, etc. Credential definitions are basically for each issuer there would be a unique or there would be a separate credential definition. So for university A there would be a specific transcript credential definition that university A will be using to issue those kind of credentials. The definition contains the cryptographic algorithm that would be used to sign those credentials by the issuer. It might also have the public keys that would be used in general to sign those, as well as some other informations. So the next step would be to issue the credential. So the university will issue that, then verifiable presentation from Alice to the company, and finally on step 8 the company would be validating the presentation. Okay. So let us go straight to the code and cover all these steps. So we will be using the same main.py file and continue writing there. So we had already configured the identity of different participants there, and now we would be extending this particular application to complete the digital credential flow. So let us ensure that the Indy pool is running. So if you do docker ps, you can see that indeed the Indy pool is running. Then let us open the text editor. So here we would be continuing from step 4. So we would be creating a credential schema, or the government would be creating a credential schema and registering that into the Indy ledger. Okay. So how do we do that? We have to define a particular credential schema. So like this, we are defining the transcript schema. It has a name, a version number, and then several attributes. Okay. So you can see that we are giving it a version 1.2, and then the attributes are first name, last name, degree, status, year, average, and SSN. So actually transcript schemas cannot be deleted, it can be updated by updating the version number. So a new one can be registered with version say 1.3. Then we will be using this particular API, we will be using it to register the transcript schema. So we are using anon creates dot issuer create schema. Okay. So we need to import anon creates also, it is not imported. So we are adding anon creates and importing it from Indy. So we are using issuer create schema, and we are passing government's DID, transcript name, version, and the attributes, okay, in JSON encoded format. So we can go ahead and print the transcript schema ID, which is returned by anon creates dot issuer create schema. So that would be in transcript schema ID, and we are also printing the actual transcript schema. So actually, to register the schema and send it to the ledger, we have to sign and submit it as a transaction. The steps for doing those are like this. So we are doing ledger.build schema request, then we are passing the transcript schema, the deed of the entity which is registering, the government's deed, and sign and submit request. So ledger.sign and submit request, this would be registering the schema into the Indy ledger. So if we run this, it would print the credential schema. So this is the credential schema. So we can see that it has one ID, and then it has the attributes. The attributes we passed. Fine. So at this point, the transcript credential schema is registered on the Indy ledger. So the next step would be to also register credential definition, transcript credential definition by the university. So the university will be the issuer of the transcript schema to Alice. Hence, the university needs to have a credential definition for the transcript credential type. Adding some new lines here so that we can see properly. Okay. So I am adding a bunch of print statements here first. So the university will be sending the transcript schema, or basically credential definition, to the ledger. So first step would be that the university needs to get the transcript schema, okay, from the ledger. So how to get that? We can do ledger.build get schema request and pass on this transcript schema ID that we obtained in line 165. So this get schema request, and we will be using ensure previous request applied method. So this is optional, but we will be using this method so that it can wait for the schema to be registered. So we will just define it above the run function here. So ensure previous request applied, it basically checks if it is available, the artifact is available in the ledger or not, otherwise it waits. Fine. So what it is doing is it is just trying to fetch the schema, transcript schema, from the ledger, and then this particular schema would be used to form the transcript credential definition. Okay. So we are parsing it using ledger.get parse get schema response. Fine. So, using that we would be now defining our transcript credential definition. The transcript credential definition will have only some attributes. One is tag, and then there is a type which is written as CL. So, that is the type of the credential definition or the algorithms which would be used for signing. So, Indy supports only this one type currently, which is CL, and we are stating that it does not support revocation. So, support revocation is false. So, Hyperledger Indy can also store revocation lists using which these the issued credentials can be revoked. Suppose the university has issued a transcript to a person or a student and it wants to remove it in future, then it has to use revocation lists to do this. But we have stated that revocation is not supported here. Now, from line 210 to 217, what we are doing is we are calling anoncreds.issuer create and store credential definition. Okay. So, we are just creating a credential definition from the schema and all the properties tag, type and configuration. So, we are using anoncreds.issuer create and store credential to create a new transcript credential definition. Now, after doing that, we also need to send that. So, we would do ledger.build cred def request. So, this would be building the request that we need to send to register the transcript credential definition, and then finally, we have to sign and submit it. So, we are doing await ledger.sign and submit request, then passing the university's deed, wallet, pool, transcript credential definition, payload, etc. So, let us run this and check. So, registering credential definition actually takes some time. So, yes, now we can see that it is successful and it is outputting the credential definition ID, which is ending with tag 1, the last line. Okay. So, we have already completed step 5. So, we have credential schema as well as credential definition. So, step 6 would be the university issuing the transcript credential to Alice. Okay. So, for issuing the transcript credential, actually the flow is not simply the university issues a credential to Alice. Instead, Alice is actually requesting a credential and university is offering a credential. So, there is a to and fro request response flow for the credential issuing part. So, before doing all those, first we have to set up Alice's wallet. Okay. So, let us set up Alice's wallet. So, we are not going to register a name for Alice because that is not required. Alice is not going to issue a credential to anyone. So, we are just going to set up Alice's own DID and save it into its own wallet. So, we are doing create wallet and then did.create and store my did, that this particular function or API, and this will create Alice's did and store it into her wallet. Now, the flow will start. So, the university first creates a transcript credential offer. So, the university is offering Alice the transcript credential and based on this particular offer, Alice would be able to create a transcript credential request. Okay. So, the first step is offer, then the next step would be request. So, let us complete offer first. So, we are using this anon issuer create credential offer, and we are passing the university's details, the wallet and the credential definition ID that would be used to issue the credential. So, this particular offer needs to go to Alice. So, actually after generating an offer, how the university will send this offer to Alice, that would be ideally done over the network or over the internet. Ideally these two would be separate applications, Alice would be independent and the university would be separate. So, the university would probably use the network to transfer this message, the transcript credential offer, to Alice. But here we are just assigning two variables. In line 246, you can see that we are just reassigning the variables. So, using this offer, what Alice can do is that she can create a credential request. So, Alice will prepare a transcript credential request. So, first we will be deserializing the transcript credential offer, which was in JSON. So, we save it as transcript create offer object, and then we extract the transcript schema ID and credential definition ID from that offer. So, actually Alice needs to prepare a master secret in order to create a request for a credential. This master secret actually ensures that the issuer will be issuing only one credential to Alice, and this would be unique with the help of this master secret. So, Alice generates this master secret, and using this master secret the issuer would be issuing this particular credential, such that without this master secret no one would be able to present it. So, for creating the request, Alice needs to get the credential definition from the ledger. So, we need a function to do that. So, let us define it here. So, get create def actually takes the credential definition ID and fetches it from the Indy ledger. Now that Alice has this credential definition ID from get create def, it can next prepare this transaction request. So, transcript request. So, Alice now will use anon creates dot prover underscore create underscore credential underscore request to create a credential request, and this takes the different details about Alice as input, like Alice's wallet, deed, the actual offer which came from the university, then the credential definition ID as well as the master secret. So, this will give output a transcript credential request, and this transcript credential request now again needs to go from Alice to the university. So, now again we will have a network call, or ideally it would be going through the network, or in some way this message has to be transferred from Alice to the university. In our case, it is just reassigning the values from one variable to another and copying the values. So, Alice's transcript credential request goes to the university. So, using this transcript credential request, the university now can start issuing the credentials. Okay. Let us run this till now. So, we can see setting up Alice, say create transaction credential request for university, send transcript credential request to the university. So, all these steps we have already done. Configuring Alice, the university getting transcript credential definition, then the request from the university, and then request or offer from the university, and then request from Alice to university. Fine. So, at this point the university has a transcript credential request. Now, using that request, the university can issue a transcript credential to Alice. So, this is how a credential looks like in Indy. So, you can see that it is a dictionary and it has the different attributes, first name, last name, degree, and it has raw values and some encoded strings. The raw value you can see Alice is the first name, then last name is this, and degree Bachelor of Science, and for each of them there is an encoded value. Actually, Hyperledger Indy does not specify any particular encoding scheme. So, it is up to the user that what the encoding scheme would be. So, you can use any kind of encoding with some restrictions. The encoding should have some formats that you can consult the documentation and find out. So, we are using anoncreates.issuer create credential and issuing the credential with respect to the actual transcript credential request that the university received from Alice. Now, we can print this particular transcript credential and we have to transfer it back to Alice. So, over the network Alice will be getting this transcript credential, and then it will be using it will be storing the credential into its own wallet. So, anoncreates.prover store credential. So, this will take Alice's wallet and the credential, the particular credential, and also the credential request that Alice used to get their credential, to finally store it into its own wallet. Okay. So, we are finally printing credential transcript credential definition. So, we should match the transcript credential definition of the university. So, this very long output is actually the transcript credential which has been issued by the university to Alice. So, you can see that the schema ID, then type CL are there, and there are the attributes, first name, last name, then master secret is also there, and then several other properties. So, till this step the issuer or the university has issued credential, verifiable credential for transcript to Alice. Now, the next step would be for Alice to make a verifiable presentation using this particular credential to the company. So, here the company is creating a job application proof request first. So, Alice is not sending the presentation directly, instead this job application proof request, as you can see, is being created by the company, and this particular proof request has different properties, and this is the most important one, requested attributes. So, you can see ATTR 1 referent, 2 referent, ATTR 3 referent. So, all of these are basically the requested attributes that Alice needs to prepare in her presentation. Okay. So, the company is requesting for several attributes, and some of them have this restriction field or restriction property. So, these are actually supposed to be coming from a particular verifiable credential, those with restriction, and then this part is also important, requested predicates. As you can see that this is a predicate which has a name, type and a value, and also a restriction, the same restriction. The restriction says the university's credential definition ID, and the JSON of this particular dictionary would be forming the job application proof request. Okay. So, this would be transferred from the company to Alice, ideally over the network, and using this particular proof request, Alice can generate her presentation. Okay. So, Alice will be creating the presentation. Before creating the presentation, of course, it needs to get hold of the credentials that are needed to form the presentation. So, in the job application proof request, we saw that there are restrictions with particular credential definition IDs. So, Alice needs to find out the credentials which can satisfy those requirements of the proof request. So, for that we are using anoncreds.prover search credentials for proof request. Okay. So, this API would be used and to search for job application proof request. So, all of them in this case would be coming from the same transcript credential issued by the university. So, Alice would be searching for the required credentials for the proof request. So, we have to define this particular function get credential for referent. So, this would be filling up or finding the credentials which are required to satisfy ATTR 1 referent, 2 referent, all of these requested attributes. So, let us define this function. Okay. So, this would be finding out the credentials from the wallet and which can satisfy the requested attributes. So, we can see that these particular there are different attributes, and then there is a predicate. So, this predicate is a particular value which would be used to which can be presented as a zero knowledge proof. Okay. So, the predicate includes a condition, and that would be used for zero knowledge proof. Fine. So, after the particular credentials have been fetched that can satisfy this proof request, these credentials can be used to form the proof. Okay. So, we are first closing the search for proof request, and then we are forming Alice's credentials for job application proof as follows. So, we are mapping these different credentials to the different referents for all attributes as well as the predicates. So, the next step would be to find fetch some more artifacts from the ledger which would be required to create this presentation. Okay. So, Alice would require the schema for this job application. So, it needs to get the schemas which are required or which are associated with the credentials that are required for this job application. So, here it would actually fetch the transcript credential schema, but we are defining a new function here so that it can actually fetch all of the required schemas in one go. So, we are defining a new function called prover get entities from ledger. So, this would take input the different required artifacts, or basically take input the presentation request, and then it will fetch all the schemas that are required for creating the presentation. So, it takes Alice's pool, deed and credential for job application proof, and then fetches the different schemas, and apart from schema it actually also fetches credential definition, and if there are any revocation lists, then those also. Fine. So, finally from line 467 we are creating the job application presentation. So, here you can see 1, 2 and 6 attributes, as you can see here 1, 2 and 6, 1, 2 and 6, these do not have any restriction, but 3, 4 and 5 have restrictions. Okay. So, these 3 do not have any restriction, and these 3, 4 and 5 have restriction. So, these are self attested attributes 1, 2 and 6, and then 3, 4 and 5 are actually attributes which are coming from a particular credential, and you can see it is marked as revealed equals true. So, in the presentation the actual value would be revealed. However, in this predicate, in this particular predicate, the actual value will not be revealed. Okay. So, the predicate will only check for the condition. So, then this presentation job application proof will be transferred to the company over the network, and at that point the company has the presentation from Alice, and then it can be validated. So, we are printing the job application proof here, and then we will be able to see what the company is getting from Alice. So, let us run this. So, there is some error here. So, get schema is not defined, it says. Let us check where the error is and let us fix that. So, indeed some things are not defined or imported. So, let us first define get schema function. Fine, and we also need to import something. So, this get schema function is actually fetching schema from the ledger. So, let us import the other required stuff. So, the blob storage, and then there is another. So, from os.path import dir name. Now, all of the things are imported, and now we can try to run it again. So, this print is the job application presentation which is received by the company from Alice. So, you can see that there is a section called proof, and then it has all the different signatures and attesting these different claims. So, this is the presentation. Now, once the company has this presentation, the next step would be to validate this presentation, right. So, we can now move to the final step, which would be step 8. So, step 8 is where the company will be validating the presentation from Alice. Okay. So, this will involve first loading the application proof, so which is the presentation using json.lods. So, after loading this, the verifier needs to get some artifacts from the ledger. So, particularly the schema, credential definitions and revocation lists if any. So, this verifier get entities from ledger function is basically almost same as the prover get entities from ledger function, slightly different. So, let us go ahead and define that. Okay. And after it has the different artifacts required, it can go ahead and try to validate all of the different claims that are there in the so it already has the schema and the credential definitions. Okay. Now it needs to do two things. First, it has to validate the claims that it wants. So, it wants to assert Bachelor of Science and Marketing in the requested proof ATTR3 referent, similarly other values in other fields, and then for the self attested fields it would just be extracting the values and checking the validating them. Finally, in line 567 it has annoncrates.verifier verify proof. So, this particular function is going to validate all the proofs that are associated with a particular presentation. Okay. So, if any of the claims are incorrect or claims do not match, then the assert statements will give error. Otherwise, this execution will not give any error. So, let us see if it gives us any error or not. It should not ideally. Okay, yes, it successfully completed. So, what we can do is we can change a particular value and see if then it gives some error or not. So, we can change a particular claim. Let us change this Bachelor of Science value to something else and then run it again. Okay, so as we can see that it is indeed giving an error here. So, it says assertion error and one of the claims did not match the expected value. So, we saw that how we can use Hyperledger Indy in an end-to-end flow from issuing verifiable credentials to verifiable presentations and validating claims from a verifiable presentation. So, we covered all these steps and you can access the source code source code of this tutorial from this link and then go through it at your own pace. So, in conclusion, we saw that we can use Hyperledger Indy for issuing, managing, storing verifiable credentials, and we can use it for creating verifiable presentations and validating them. However, we found that there is a gap of a way to transfer these different credentials and presentations between the different parties. So, in the tutorial we were simply copying variables or copying values from one variable to another, But in the real world, these participants would be running their own separate applications, and they would need to communicate, and that communication can be handled by several other platforms such as Hyperledger Indy, which we would cover in the next lecture. Thank you.